All right, last example, differential equation. Okay, notice the initial condition this time. F of 0 equals 0, so that doesn't tell you whether y is positive or negative in the equation. Okay, let's do this. Remember, 6 points on the AP exam free response. Okay, let's get it. Let's separate the variables. Look, I already cross multiplied. Okay, and I have dy is equal to 1 minus y times 2x dx, and then I just divided this over to the other side. So I skipped that step when I jumped over here. Now there's a typo here, so you're going to have to pretend with me that this is not here. All right, because I can't fix it without doing the whole thing over again. This should say 1 minus y. All right, so pretend with me. It's dy over 1 minus y. So I'm going to integrate both sides, find both antiderivatives. So I've already got 1 point. Now I'm going to see if I can pick up a point for the left side and the right side antiderivative. So for the right side, I have x squared, and then for the left side, I have ln the absolute value of 1 minus y. Okay, because remember, taking the antiderivative of 1 over y, dy, is equal to the ln of the absolute value of y. So this is literally the same thing, okay, except it's 1 minus y. Now, if it was 1 minus y squared, I wouldn't say ln, it'd be something different, okay? So anyway, it's 1 minus y to the first. So I have the absolute value of the ln of 1 minus y, and there's also another typo in here, and if that's if u is equal to 1 minus y, then du is equal to negative dy. So dy is equal to negative du. So there should be a negative sign here, okay? Now I'm going to use my initial condition. So I got 3 points here, 1 for the antiderivative on the left, 1 for the antiderivative on the right, and 1 for writing the constant of integration. So I already have 4 points total. Okay, I'm gonna put my negative sign here. Okay, now I'm gonna use my initial condition, and you get another point for using your initial condition in solving for C. Okay, so I plug in 0 here and 0 here. So I end up with the ln of 1, which is 0. And remember, there's a negative sign on the outside, so that's just negative 0, which is still just 0 because 0 is neither positive nor negative. So C equals 0. And now I got 5 of the points. Now I have to go and write the equation in terms with y by itself. Okay. So I'm going to have to rewrite this without the y stuck inside the ln. So the only way to get the y out of the ln is to write it as an exponential function. Okay. Now I could just put this negative over here, divide that over, and have this as the ln of the absolute value of 1 minus y is equal to negative x squared. So that would be e to the negative x squared equals the absolute value of 1 minus y. And since it's an absolute value equation, it's a piecewise function. So that means I have that 1 minus y is equal to plus or minus e to the negative x squared. Okay. Now, I move the 1 over. And now I have this, and I divide by the negative 1 over. Or I could move the y over and then just move this over. Doesn't really matter. But now I am here. Okay, now the question is, which one do I keep? Okay, so I'm going to plug in my initial condition. So this is what I always stress. Plugging in your initial condition to make sure that you keep the right version. Okay, so I'm going to plug in 0 here for x, 0 here for y. Okay. So I end up with e to the negative 0, which is the same thing as e to the 0. So I end up with 1. Okay. So the only way that I'm going to get 0 on the left-hand side is if I do 1 minus 1, because I have the 1 plus or minus 1. I'm going to keep this one. Okay. So that's how I know that it has to be minus in my equation. So when I write my final equation, it looks like that. I kept the minus version. That's it.